the second part of design tools, and basically talking about verification tools. Fairly low level. The first thing we'll talk about is design rule checking. It's still kind of big picture, but we'll look at some design trade-offs. So design rule checking is basically the process of verifying that your layout will meet the physical constraints of the fabrication process itself. That means that if you follow these design rules, it's very likely that your design will be fabricated and it won't encounter any issues such as two metal layers being too close together, which may have otherwise caused a short circuit, for an example. So a design rule violation is a geometry that doesn't meet the specified rules of the fabrication process. One of the things you can take advantage of with DRC is hierarchy, and the basic idea here is that you completely DRC the lower level cell, and then at the higher levels you really worry about the connectivity of the cells. So you check the lowest level completely, and then at the higher levels you only have DRC at the edge of the cells. So you're basically assuming that the inner contents of the cells are going to be manufacturable. In order for a DRC program to correctly function, it probably also has to be able to determine connectivity information. And an example there might be metal 1 and metal 2 were connected by a via, so you'd have to be able to determine that the via connected those two layers together. And otherwise, it may have been a design rule violation that's not really one if they're electrically connected. So here's a couple of techniques for looking for design rules. The simplest is just a raster scan, and this is passed over the layout and looks for very simple design rule violations. And a simple example that's coming up is this showing a metal separation less than 3 lambda, where lambda would be some parameter associated with distance. So if the window matches the pattern, a DRC is found. Of course, there's it may report incorrect violations. If two metal wires are electrically connected, it may be possible that you could separate them less than 3 lambda, but a raster scan technique wouldn't pick that up. It's very good for Manhattan type geometries, and those are grid-like patterns that you might find in Manhattan, in fact, whereas non-Manhattan geometries are basically those that are non-orthogonal and a little bit more difficult to use a raster scan DRC on. Anyway, here's a simple picture of a couple of masks. One is going to be the vertical separation window, so it'll make sure that the metal wires are separated by 3 lambda vertically, and when the template is passed over the image, the horizontal separation window would tell you if there's a design rule violation when you scan that template horizontally. Other types of techniques can be based on polygons, so some operations on the polygons, they're kind of logical now: and, or, XOR, touch, merge, bloat. And for example, you could have a design rule violation if in fact you bloated a polygon by 1.5 microns and it happened to touch another polygon which is bloated by 1.5 microns. So that would mean that they weren't separated enough. So these techniques can be quite computationally intensive. And here's simple examples of 3 polygons shown there with some of the operations, like B touching C, an AND is where they overlap, an OR is the entire region which is contained by polygons A or B. Merge is very similar in that particular case. And then an XOR would be where either are but not both at the same time. And bloat, as you might imagine, just extends the perimeter of the polygon. Other types of DRCs are based on corners, because all the polygons are typically defined as corners, so it's a matter of scanning through all of the corners associated with a polygon in a given layer and making sure that you don't have a design rule violation. Again, it would be template based, and here's a simple example of one which is based on a 3 lambda metal separation. That would be the template, and that would basically be the corner, and it can rotate depending on the orientation of the corner, making sure that you don't have metal that would be infringing on this metal here, which would make it a design rule violation. So these all tend to look like computational geometry techniques, which they are. And if you wanted to dig a little further into this, you could look at some layout and DRC examples, and they're found at that website that's given down there. And basically it's a layout editor that you can download and play around with, and it has a design rule checker in it. The only time you're likely going to encounter things like the design rule checking is actually if you're building a MEMS type device, where you're down in the low level details of the silicon itself. And this time we'll take a break.